So part two, here I am back again. So I'm supporting it. I've got my finger on the top, finger on the bottom, but I know it's symmetrical on both sides. I've got right, nice, evenly balanced, so I'm gonna say it's gonna be balanced. 1, 2, 3, balanced. All right. So another thing that really helps to make an object balance has to do with weight. And the fancy word for weight when you're a scientist is called mass, M-A-S-S. Do I have it on the board? It's around here. There it is, mass. I don't even know if you can see it. So mass can definitely assist sometimes to make something balanced. You have to move the weight or the mass around. So when you're thinking about balancing on one leg, you have to put your arms out to help move your mass, move your weight to help keep yourself balanced. That's where these clothespins come into play. I think you're probably smart enough to know, what do you think is going to happen if I just put some weight on one side of this crayfish? Take your guess right now. Are you right? 1, 2, 3. Yeah, it's going to fall. Gravity's going to pull. There's more weight on one side, so gravity, Earth's force, is going to pull it and plop on the ground it goes. But if we add equal mass, counterweight, so we had the weight on one side, the counterweight on the other, cross your fingers. It's been a while since I've done this. 1, 2. Oh, no, wait, it's not, see, it's not always working. Whoa, it's not working very well. Uh-oh, that's kind of hard. I'm gonna move my weight and counterweight around and maybe more towards the outside. Can that get it to balance? Well, there it is balanced, but look at it. It's kind of balanced flat on its back. So yes, it is technically balanced. And as you can see, I've been teaching this for years, and still the first time I couldn't get it to work very well. So how can I tell it's balanced? Well, number one, gravity hasn't pulled it and it's not gone kerplop on the ground. But also, if you give it a teeny tiny tap test, do you notice how it wobbles and bobbles back and forth? If you do a teeny tiny tap and it doesn't fall down, it's balanced. We've got the center of gravity, and then we've got the point here where it's touching my finger. Now, this is a really hard term. Are you gonna remember this? Do you know what the point is called? Where it's the center of gravity, where it's balanced? It's called the balance point. An easy one, I love it. So that is the balance point. So what I would like for you to do is you can pause my video if you like for a bit, and then right now, try it yourself. Move the weight, move the counterweight around. I'm moving it in a little bit more like this, and as I move it, now it's standing up a little bit straighter and taller. So as you move the weight, as you move the mass around, it's going to change how it's balanced. So just make sure that if you're moving it, if you move the weight, you better also move the counterweight, because otherwise it may not be able to balance as equally. So I'm going to let you take a break, pause for a second, and then do a little bit of experimenting on your own, and then I'm going to come back. Well, I'm not going anywhere, you're pausing me. So I'll just wait a second, and why don't you pause and see what you can do with your paper crayfish. I'm back. So, did you try different things? You can also try to move your weight and counterweight in different parts of your crayfish. So you can move it on the sides. You can try having it on the bottom. You can try it somewhat on the top and on the bottom. Let's see if that works. Looking at this, do you predict it will balance, or will it go kerplop? Take your guess. 1, 2, 3. Kerplop, down it went. So the weight isn't even. Now, even though now this shape is not symmetrical on each side, if you have the weight and the counterweight evenly distributed, you can, oh, it's gonna fall, so I'm gonna adjust. Get used to this unit in science, boys and girls. Things will go kerplop a lot. And you know, scientists don't quit. Scientists do hundreds, thousands of experiments. And you know what most of the time happens? They fail. It doesn't work. But they don't go, hey, it doesn't work, I quit. No, they try again. And they change what they do just a little bit and see if it works. So I'm going to change mine a little bit. Not working too well. Let's see if I go this way. Will that work? Sometimes if you just play around, you can get it to balance okay. I'm going to put one maybe on the front here and maybe on the back here. Let's see what I can do here. Can I get it balanced that way? Oh yeah. So that can work as well. Now do know that while this is balanced, do the teeny tiny tap test, it's balanced shape. If I were to go like this, it's actually not balanced. This is supported. So my hand, my arm is actually holding it up. It is supporting it. So this is not balanced. If it's on just a smaller balance point, and see I'm moving and adjusting it because otherwise it's gonna go kerplop, it can be balanced that way. So take a couple minutes and see how many different ways you can get your paper crayfish to balance. Here I am again. Now I'm being silly. Hopefully each time I'm stopping, you're pausing. If not, hey, you're just seeing Mrs. Donahoe act like a fool, which is pretty normal for me. But I'm a science fool. So we've learned that objects need to have equal, even weight to be balanced. We want the center of gravity right down in the middle, equal weight on either side, or weight or counterweight, because otherwise it's not going to be balanced. It will be unstable. So when it's balanced, you would call it in a stable position. I'm going to make it one more time, show you my stable crayfish. Got my weight. Oh, I forgot my counterweight. If you don't have that counterweight, kerplop, gravity's going to pull it to the ground. So I've got my counterweight now. And so now it is in a balanced / stable position. Teeny tiny tap, oh yeah. So go now, when you're done with our paper crayfish, find something at home. See what you can balance yourself. Try something like a pencil, a ruler. I had a student, Eli, show me a really neat balancing trick, and I think he found a potato. But if you have things like forks, I've got forks here and I made a little ball of clay. You can get something like a potato or just something soft. And if you stick this in one side and then stick it in the other, so you have two forks, you're gonna have your weight and your counterweight. And if you get it just right, you can also then have a balancing point. So that's what we've learned today for science. We've learned about something that is balanced. We have the center of gravity, equal weight, counterweight on both sides. When it's balanced, it is in a stable position. If the weight is not balanced, if it's not even or equal, it's going to, this time it didn't go kerplop. Isn't that interesting? It can sometimes go kerplop, but see, I've got enough weight here from this clay ball, so it didn't go kerplop like I thought it would. Oh, well, I'm not going to retape this whole lesson just because this worked, but it's kind of fun. Anyway, I hope you enjoyed science today. I would love it if you get a chance just to take a picture on Seesaw and post it with you balancing either your paper crayfish or balancing something at home, and we will see you next week for science. See ya.